Welcome back, dear student. In the previous class, we had discussed regarding the frictional force and types of frictional force. So, in this class, we are going to discuss regarding the laws of friction. So, laws of friction state that the frictional force is always directly proportional to the normal reaction. So, directly proportional to the normal reaction. And the next one, the frictional force depends on the nature of surface of a body in contact and their roughness. So here nature of body, nature of a surface, nothing but it may be wet or dry or it is rough or smooth. It is the nature of a surface of a body. And next one is frictional force does not depends on the nature of surface of a body in contact. It does not depend on the area of surface, but it does not. It depends on nature of surface but it does not depends on the area of surface. And next one is the direction of frictional force is always parallel to the surface area of a two bodies. It is always parallel and opposite to the motion of a body. It is always opposite to the motion of a body. And the next one is the kinetic frictional force does not depends on the relative velocity between two bodies. It does not depends on the relative body. So relative velocity means velocity of one body with respect to another body. Here the kinetic frictional force does not depends on a kinetic velocity. Relative velocity between two bodies are in contact. These are all the laws of friction. And the next topic is how to reduce the frictional force. So the next concept is method of frictional force reduce. These are all the method to reducing a friction. The first one is friction can be reduced by polishing. So when we polishing a surface, we can reduce the friction of a two surface. And the next one is ball bearing. So rolling surface or sliding, rolling surface is very less friction than the sliding one. So the here free wheel of a motor car or a shafts of motor etc. are provided with a ball bearing to reduce the frictional force. And the next one is lubrication. The friction can be reduced by lubrication. The friction can be reduced by lubrication means we use a suitable oil or grease to reduce the friction between two surfaces. That process is called as lubrication and that material is called as lubricant. So lubrication means we reduce the friction by using suitable oil or grease. Then only the surface friction of that surface will be reduced. That is called lubrication. Next, streamlining. Streamlining here, automobiles and aeroplanes are used streamline to reduce the friction due to air is called as streamlining. And the last one is by reducing the friction by maintaining a cushion of air between solid surface. These are all the methods to reduce the frictional force. And the next topic is banking of road. So banking of road here means when a cyclist travel or move in a curved path, it tends to divert inward in a curved path. Then he obey a centrifugal force to the cycle. He gives a centrifugal force towards the inward of a curved path. Then the banking of road is required. So then what do you mean by banking of road? Banking of road means provide a necessary centrifugal force to the vehicle that is called as banking of road. The necessary to provide a necessary centripetal force to the vehicle, that is called as banking of road. So here next one is angle of, for example, this is a curved path, a cyclist moving in this direction, then here when he travel the direction of travel is in a circular path, then he tends to move in circular path in inward direction. It's towards the center. The force of attraction taking place between the center towards inward direction, that is called as centripetal force. Here cyclists obey the centripetal force, that necessary centripetal force produced by himself to the vehicle is called as banking of road. Then what is the angle of banking of road? So what is the angle of banking of road? Here the angle between the inclined surface to the horizontal surface of that road is called as angle of banking of road. So this is regarding about the banking of road. When this condition, the upper edge of that, when the centripetal force acting on a cycle by cyclist, the upper edge of the road will be suitably raised than the inner edge of a road. This is called banking of road. The next one is derive an expression for maximum safe speed of a vehicle on a banked road in circular path. This is the important derivation. So in this diagram here, this is the vehicle, this is the 2 points on a curved path. This is vehicle, this is banked road, this is the horizontal road. So here the point center of O. In this diagram, OA is the level of curved road. Here OA is the level of curved road and OX is a horizontal line. OX is the horizontal line and OA is the level of banking curved road. It is the level road of a banking road. Where theta is the angle of banking. Here that theta is the angle of banking road. Then N is the normal reaction and R is the distance from O to vehicle. O to vehicle is the distance R. From this diagram we have where n cos theta is equal to Fs sin theta plus mg. We have from this diagram, from the figure, we have n cos theta is equal to Fs sin theta plus mg. Here Fs stands for static friction. So what do you mean by static friction? It will be studied in the last class itself. So static friction means it is the frictional force when the effect comes when the body tends to move, not moving, it is tends to moving, that is called as static friction. So here for maximum safe turning speed Vmax equals to maximum speed is equal to, that is Fs equals to Fs maximum maximum, that's equals to mu s n. Here n stands for normal reaction. Mu s means it is the coefficient of static friction. Mu s means when mu s is the coefficient of static friction, and n is the, where n is called as normal reaction, that's equals to, n means normal reaction, that's is equal to mg. So next we have substitute the value of Fs equals to, here the first equation Vmax equals to, here n can, from the derivation, n cos theta can be defined as Fs sin theta plus mg. So here n means normal reaction. Then substitute the value of Fs equals mu s n to this equation number 1. We get n cos theta equals to, Fs means mu s n sin theta plus mg. So substitute the value of this to this equation. We get, in the place of Fs we substitute mu s n. Mu s means mu s is the coefficient of static friction, and n into sin theta. So here this term comes to left side, n cos theta minus mu s n sin theta equals to mg. So now in the both term n is the common, so take it outside, n of cos theta minus mu s of sin theta equals to mg, and simplify n equals to mg divided by cos theta minus mu s sin theta. So this is, let us equation number 2. But from the centripetal force, from these diagrams we know that the centripetal force is given by here centripetal force means formula for centripetal force mv max square divided by r is equal to n sin theta plus fx cos theta. N sin theta plus fs cos theta. This is the centripetal force from this diagram. Now here substitute the value of n to this equation. Here substitute value of fs, mv square equals to r into n sin theta plus mu s n cos theta. So here substitute the value of n here. n means mg divided by cos theta minus mu s sin theta into sin theta plus fs cos theta. So here fs means, the value of fs means mu s n. So here in the both side mv square mvx max divided by r. In both side m is common term, so it's deleted. Then next one is remaining v max square is equal to rg into sin theta plus mu s. So here in this step we taken n is common term, so n is common, n into cos theta divided by cos theta minus mu s sin theta. So here this is the actual expression. Then here divide cos theta for both numerator and denominator for the right hand side. Dividing cos theta, we get v max whole square is equal to rg into sin divided by cos is tan theta plus mu s n. So here mu s n is common, cos divided by cos is cos by cos is 1, so neglect it, and whole thing divided by, here cos means cancel, 1 minus mu s tan theta. So I will write again here. So this is the expression for a maximum velocity when the maximum safe speed of a vehicle in a banking road. So again I will write here v max whole square equals to rg into tan theta plus mu s n divided by 1 minus mu s tan theta. So here where mu s is 0, why? Because static friction, there is no coefficient of friction in this static friction. Mu s is 0, there is no friction in this state, therefore mu s equals to 0. Substitute this here, v max square equals to rg into tan theta divided by 1. So divided by 1 means remaining as it is, rg by tan theta. Here mu s is 0 when v max equals to square root of rg tan theta. When friction coefficient of static friction is 0, then v max square equals to rg tan theta. We remove the square, it takes in the right side it is square root. V max is equal to square root of rg tan theta. Where it is maximum, it is in horizontal line. Then theta becomes 0. Then tan 0 is 0. Tan 0 is 0. V max equals to tan 0 is when tan 0 is 0, this final equation become tan 0 is 0. Therefore, V max square equals to, here tan theta is 0. So this term is vanishes, remaining rg mu s equals to square root of rg nu. Yes. So this is the maximum speed when the vehicle travel in a banked road in a circular path. So this is very important. So write down. And the next concept is equilibrium. So body is said to be equilibrium. Then what is the condition for equilibrium? When the force of vector sum of all the force acting on a body is 0, or it is 0 or moving in a constant uniform motion, then only body is said to be equilibrium. This is regarding about the equilibrium motion of a body and also banked road of a vehicle travel in a circular path. So this complete your the laws of motion chapter.